Good morning, everyone, and welcome to math. Let's go ahead and pause our conversations and start getting out our materials. Today we are going to need our notebooks and a pencil and a whiteboard and all of those materials. While you're grabbing those supplies, let's talk about what we're going to be learning today. So we're continuing with SOL 6.13, and just a reminder, that is solving our one-step equations with all of our operations. Well, we've already learned about how to do it when we're adding and subtracting, and we got really good at that. So now we're going to move on to our next operation, which is multiply. So by the end of this class today, you will be able to solve a one-step equation with multiplication, and you will know it when you can successfully solve for the value of x and check your work. So our agenda looks like we're going to do a little review of vocabulary and SAD MEG. So let's think about, in our own words, how to describe those. I'm going to call on some of you. And then we're going to learn how exactly do we use SAD MEG to solve our equations when there's multiplication. And then we're going to move into our ketchup, mustard, and pickles and get some more practice. So let's get started with our vocabulary review. At this point in the lesson, I would offer the terms coefficient, variable, operation, constant, and solution and equation to the students. I would have them explain it in their own words just to get them familiar with what that looks like in an equation and what those terms mean. I would chime in when necessary to help with those definitions as well. All right, thank you for everyone who helped us review our vocabulary terms, and now we're going to look at SAD MEG. And who can tell me, why is Meg sad? Why is she sad today? Yes, because we do not know what x is. And if we know what x is, we can solve, right? But we don't know. We don't know what x is. So can we solve using our order of operations, our GEMDAS? No, we cannot. And that's why Meg is sad. But SAD MEG tells us that we can find x, right? That we can do the opposite. Great job. Yes, SAD MEG is the opposite of our GEMDAS, right? GEMDAS, SAD MEG. So she tells us that when we don't know what x is, that she's sad, and that we can do the opposite operation in order to solve. So we learned earlier this week that the opposite of subtract is add, and the opposite of add is subtract. So if we're talking about multiplying today, what is the opposite of multiplication? Yes, exactly. It's division. Great job. Something that's really important that we're going to see with our equations, especially because now we're 6th graders and we're getting into having those variables, those letters in math, is it's not going to have 4 times x, right? Because then we're going to have 4xx, and that's confusing. Instead, we're going to have 4 and x smushed together like you see on our screen here. When we have a number and a letter smushed together, we can remember to smush our hands together and look at our thumbs. And what operation does that make? Yeah, a multiplication sign. So when 4 and x are smushed together, we know that means multiply. Well, what did you all just tell me was the opposite of multiply? Division, exactly. So in this example where we have 4 and x smushed together, we know that that meant multiplication, and SAD MEG told us we have to do the opposite of division to get x all alone. Great job. Well, let's take that and look at an equation now. So now we have the equation 2x equals 10. We should be writing this down in our notebook as an example. We have 2x equals 10. 2 and x are smushed together. And that means multiplication. Great job. But we don't know what x is. We don't know. We don't know. We know that this means 2 times something equals 10. Even if you know it, don't shout it out. So let's think. If they're smushed together, that's multiply. So we need to do the opposite, which is to split them apart, to divide. So instead of multiplying by 2, we are going to divide by 2 here. And we know that those are going to cancel out, and we're going to get x all alone. Let's think back to when we looked at our scale the other day. If I'm going to do something to one side of my scale, did that keep my scale balanced? No. And what's so important about equations is that we keep them equal, right? So I need to do the same thing that I did on this side to the other side to keep my scales balanced. So where else should I divide by 2? Yes, on the other side of my equal side, where the 10 is. So now we were able to get x all alone, and we have 10 divided by 2. Remember, we can use our calculators here, or maybe we have that memorized. And what is 10 divided by 2? Yes, great job. It is 5. So we get x equals 5 here. But are we done with this problem? Or do we have one more thing we need to do? Yes, great job. We need to check our work. We always have to check our work to make sure that we got our answer right. So we go back to our original equation where we had 2x equals 10. But we solved. We did it. We found that x should be 5. So we're going to plug that in. So now we have 2 times 5 equals 10. And is that true? Yes, 2 times 5 is 10, and 10 equals 10. Great job. All right, let's look at 2 more examples together before you try some on your own. So here we have our negative 2x equals 14. Negative 2x equals 14. Remember, we should be jotting this down just like we see it on the board, so we have examples to look at. Again, we have negative 2 and x, which are smushed together. And what operation does that mean? Yes, great job, multiply. So we know that we're going to do the opposite of multiply, which is divide. Great job. But the question I have here is, do you think we should divide by positive 2 or negative 2? I really like the voting that we have going on here. So let's look at this. It is a negative 2. That negative belongs to the 2, not to the x. So if we want to get x all alone, we have to divide by the negative 2. We don't care about what negative x is. We want what positive x is. So we are going to divide by negative 2. And that got x all alone on one side of our scale. But are our scales equal right now? Or do they look like this? Yeah, they look like this. They're not balanced. So to get it balanced, we have to do the same thing to what number? Where else do we need to divide by negative 2? Yes, the 14. Remember, we're not pulling numbers out of thin air here. We're taking what they gave us. We're taking the 14 and dividing by negative 2. This is really important where we go in order down our lines to see that it is 14 divided by negative 2. Not negative 2 divided by 14. And we have our calculators if we need them, or we can think about our MD Fox that we learned earlier this year. We have our positive divided by a negative to get a negative. Great job. And 14 divided by 2 is 7. So we know that x should be negative 7. But are we done there? Nope, we got to check our work. So we go back to our original, negative 2x equals 14. We said that x should be negative 7. And, well, negative 2 times negative 7, does that equal 14? Positive 14? Yes, it does. Because a negative times a negative gives us a positive. Great job. All right, the last example that I want to look at today before you try some on your own looks a little bit different. This one says negative 12 equals 4x. It's backwards. Is that okay? Yes, because our scales are still balanced, right? It's still balanced. We haven't touched anything yet. Negative 12 can be on the other side. That's okay, because we know that we're solving for x. So we have to look at what math is happening to x. Well, what numbers smushed together with x? 4, exactly. So even though it's flip-flopped, we're still going to do the same steps. So 4 and x were smushed together here. So we have to do the opposite, which is divide. And are we only going to divide on one side of our scale? No. We need to divide on both sides of our scales. So here we do have 4x, so we need to divide by 4. And that gets x all alone. And on the other side of our scale, we had negative 12. So we need to divide by 4 as well. And who remembers or who has a calculator and can tell me negative 12 divided by 4? Great job. Is negative 3, right? A negative divided by a positive gives us a negative. Are we done there? No. Let's check our answer. So we're going to take our original negative 12 equals 4x and substitute in negative 3 for x. And what was 4 times negative 3? Yes, it was negative 12. So that is, in fact, our answer. All right, so now we are going to do a couple practice problems on our own just to make sure that we got it and that we are ready for our independent practice today. So go ahead and remember, in your notebook you have examples to look at. On your whiteboard you need to be working out all of your work. I need to see every step, not just what x equals. And that includes your check. So go ahead and try this one. 6x equals 18. At this point in the lesson, I would allow the students a few moments to work on this problem. I would be checking in with students who need a starting point maybe or need some additional assistance, specifically checking on those kiddos who have the math calculation deficits and who have displayed that they are not proficient in this area or have struggled previously on our other one-step equation lessons. And I would do a couple different examples with these, including what we saw in the teacher-led instruction, so including the negatives, including some where x is on the right side versus the left, and I would go over all of these one by one. So we would do the first example, they would try it, we would go over it together. We'd move on to another example to facilitate that learning and to give them a little bit of independent practice before truthfully going independent. All right, great job everyone. Great job with all those examples. I'm super proud of you all. Now we are going to move into our ketchup, mustard, and pickles part of class. So remember, it's on the board if you're not sure what comes next. So the first thing today for ketchup is if you have any activities left over from the add and subtract, maybe you missed or maybe you just know that you need a little more practice or we didn't quite get through everything. We're going to catch up on that today. Your mustard, your must-do is you have 2 activities that you are going to be practicing. The first is you are just practicing checking an answer. So it'll give you an equation and it will say what x equals. And you have to check and see, is that true? And if it's true, you're going to draw a smiley face next to it. And then your second activity today for your must-do is you are actually solving these equations. And remember, I need to see all of your work, and that includes your check. And then you have 10 minutes of your iReady or iExcel, depending on where we're at. And then you also have your pickles activities. So if you finish both your ketchup and your mustard, you have your anchor activities, your graphing homework, and your SAD Meg poster. At this point in the lesson, I would dismiss the students to work on those activities. That gives them a little bit of freedom in what they want to work on first. Do they need some more add and subtract practice before we move on? If there are students that have missed or I think really need more individualized practice, this is the point where I'm going to pull those students into a small group. I'm specifically going to start with the students who are working on not being proficient at this time or have those math calculation deficits, just to really check in and make sure that they are ready to work independently first. A little bit of explanation for the pickles activities. Those anchor activities are going to be enrichment activities, taking skills that we have already learned in the school year and are reviewing them to get ready for end of year testing and building upon those skills. A little bit of a challenge to see what else they can do to challenge those students who are advanced already and are going to go through some of these activities a little bit faster than the students who need some more work. The graphing homework, with the 6th grade being introduced to the coordinate plane this year, that is just a practice of graphing points, and that's something that I typically have students work on all year long in the 6th and 7th grade, is practicing that graphing to make sure that they're ready for functions. And then with the SAD Meg poster, SAD Meg is something that I use to teach equations and to teach the steps, and that's again something that they're going to follow through 6th, 7th, 8th, and the rest of their time as a math student, is solving equations. So that poster would be just a fun, creative activity where they get to talk about SAD Meg, explain the steps, and draw a cute little picture that we can later post around the classroom or share with classmates. During this time, I would be specifically, if I'm not working individually with a group, I'd be walking around, working with some students who need the more support. I did teach this class as if I was a collaborative teacher. My collab teacher at this time for this lesson would be checking in with students while I would be leading the group lesson, maybe dropping down, working with individually those students that need some more support. During this time, my collaborative teacher would also be able to check in with the students who are advanced and are flying through this practice and are showing that they are really grasping and mastering this subject, to enrich them and add some more difficulty and level for that. These activities would also be differentiated with modified for the students who have, those math calculation goals, who are overwhelmed by, 9 problems, instead giving them only 3 at a time and just letting them work through those step by step, because that is what the goal here is, to show the mastery of those steps, not to show that they can do 20 problems in one day.